Hey everybody, Math by the Moon. Today what I want to share with you is how to simplify powers of I. So let me share my screen with you. We can do some problems together. And let me hide this video panel. Okay, so what we already know about I is that I is equal to,
Interesting question.
the square root of -1. Sorry, my Siri's talking to me. Every time I bump that, it does it. So that means that I to the 1 equals the square root of -1. So our goal would be to simplify powers of I so that they're not so high. So I could write over here the square root of -1, or I could write just an I, and I want to keep the answer over here as a power of I. Okay, so let me make sure I'm first into my thing the way I'm supposed to. Clearing annotations. Sorry. So, So what I said we know is that I equals the square root of -1, which is still equal to I no matter what, or the power of 1. So right here, I'm going to say that's just regular I. Now I squared is really the square root of -1 because we're doing some substitution for I. Right? So from above, I squared, I equaled the square root of -1. So remember what happens when we have a pair of identical factors with a square. And this is really saying the square root of -1 times the square root of -1. So that would just equal -1. And a lot of times in math class, you'll hear me say that the square and the root cancel each other out. Specifically in this case, the square cancels the square root. So literally I squared is -1. I to the third power, well, that's really I squared times I. And we know that I squared equaled -1, right? So that's really a -1 times I. That I doesn't change. So what the answer to this really ends up being is -I, -1I, or -I. Sometimes I'll call it I cubed as my pirate power of I because he's -1I. You can laugh if you want on your own. I'll believe you did. I to the fourth is really, we could do this a couple of ways. I'm going to go the I squared approach. I squared times I squared. And I know that both of these I squareds equaled -1. So this is really -1 times -1, which is a +1. Okay? So there's our first 4 rotations, and that's going to be very important moving forward. I to the 5th. And I to the 5th, you're going to see that's I to the 4th times another I, right? And I used I to the 4th this time, and I could use any iteration of the i's up here and do some substitution until I can create that. But I to the 4th is the easiest because it's a 1 times an I. So that's an I for I to the 5th. And I'm going to draw a little line right there because that's where I said that's where the first cycle of 4 was. And I just want you to see kind of where things begin to come up with our, maybe you'll see a pattern. I hope you see a pattern. I to the 6th, again, I'm going to use I to the 4th because it's bigger, and that leaves me with I squared that I have to also use. I to the 4th is 1, and I squared is -1. So this would be -1. So again, z to the 5th is I, z to the 6th is -1, z to the 1st was I, z to the 2nd was -1. I'm wondering if z to the 7th is going to be the same as z to the 3rd. So let's figure it out. And you're probably thinking now, I'm going to jump all the way to I to the 4th again. And then I'm going to use I cubed. So essentially, anytime we're past I to the 4th, we're going to use as many I to the 4ths as we can. Right? We're going to use as many of these as we can. And whatever that leftover value of I is, like this, because I to the 4th is 1, whatever that leftover value is truly what we're going to have for our answer. Here again, this is 1 times my pirate negative 1I, negative I. So what's that equal? Negative I. And now with I to the 8th, you probably don't have to see me write that. It'd be I to the 4th and an I to the 4th, which is 1 times 1, which is again a 1, right? So what we're seeing here is really anytime we have a power of I, a positive power of I, we're going to see that this can be divided by 4 and figure out not so much what the answer is, but the remainder. The remainder will tell us where we fall in this sequence of I in terms of our simplified answer. So you're going to see something like me copying down I, negative 1, negative I, 1 a lot, because I know that that's a 1, a 2, a 3, a 1, a 2, and a 3, and a 4. Really, 4 is kind of my 0 remainder. All right, so let's go with a new slide here and see if I can hit. Let's go this route. How about I to the 14th, right? So if I take 14 and divide it by 4, that's going to give me, without going over, that's going to be I to the 4th 3 times, right? And we know that any I to the 4th is 1, right? And this only accounts for 12 of the 14, so I still have I squared. And I'm trying to get you to a place where you don't have to constantly do this breaking down, so we can eventually make a rule. This would be a 1, and I squared, we had our previous slide for what I squared was, and I squared equaled negative 1. Okay, so this is 1 times negative 1, which is negative 1. So what we're seeing here is I to the 14th equals negative 1. So what we can do is just think of it as dividing this by 4, and whatever our remainder is. 4 goes into 14 3 times with 2 left over. Let's just find the power of 2 that we want in our sequence of i's, remembering that I squared is negative 1. I to the 14th is negative 1. I to the 18th. If I divide that by 4, it has a remainder of 2. So anything with a remainder of 2 is going to have an answer negative 1 again. So I to the 18th equals negative 1. Anything with a remainder of 3, right? So I to the 19th, if I divide that by 3, that's going to give me a remainder of 3. Right? So the remainder of 3 is the same as I to the 3rd. I to the 3rd is negative I. Okay? So if I have 0 remainder, like I to the 200th, right? That's divisible by 4. That goes, so if it's divisible by 4, it's the same as anything that has a remainder of 0, like the 4 does, right? 4 divided by 4 has no remainder. So this is a remainder of 0, just like I to the 4th. Okay, so this works for any positive power, okay, specifically positive powers of I. If you divide it by 4 and you check the remainder, that's going to tell you what power of I to follow in that chart. All right, so hope this helps for positive powers of I. I'll be doing one for negatives.